Ghana Teacher Licensure Exams 2025. So there is a test on sets, and for sets we are going to look at 2 and 3 set problems. The aim of this particular test is to prepare candidates who will be writing JHS mathematics. So in your course outline, you're supposed to revise on application of sets, and this particular test will help you do that revision. So in this particular test, we have 15 multiple choice questions that covers 2 and 3 set problems. So without wasting my time, let's begin. Question 1. In a class of 40 students, 30 read economics and 20 read history. Each student read at least one subject. So how many students read both economics and history? So to solve questions involving sets, it is always advisable to represent the given information on a Venn diagram. So we have our Venn diagram. So let's begin. So we are told that there are 40 students in the class. So the universal set here is 40. And then we have 2 different subjects. The first one is economics. So I'm representing the first circle with E. That is for economics. And then the second circle as history. So H for history. For economics, there are 30 students, and then for history, we have 20 students. We are told that each student read at least one subject. What's the meaning of this particular statement? Each student read at least one subject, meaning that the number of students who read neither economics nor history is 0. So neither of the 2 subjects is 0. So that is the meaning of each student read at least one subject. So how many students read both economics and history? So both economics and history will be the intersection of these 2 circles. So this particular region. Since we don't know the exact number, we are representing that with a variable A. So when we look at the economic circle, we are having 2 regions. And when you sum up these 2 regions, that should be equal to 30. So if one part is A, then the remaining part must be 30 minus A. Again, for the history circle, we have 2 regions, and these 2 regions must sum up to 20. So if one region is A, then it means that the remaining region must be 20 minus A. In a 2-set problem, basically we have 4 different regions. So this is the first region, the second region, the third region, and then the fourth region. When we sum up these 4 regions, it should give us the universal set. So the first region, we have the expression 30 minus A plus the second region, which is A, plus the third region, we have 20 minus A plus the fourth region, 0. So this must be equal to 40. So let's simplify. We have 30 plus 20 plus 0. That gives 50. We'll also see that some of the variables can cancel out. Negative A, positive A. These 2 can cancel out. We are left with minus A, and this must be equal to 40. So we are grouping like terms. I'm grouping numbers on the left, variables on the right. So on the left, we have 50, so minus 40, and this must be equal to positive A. This gives 10 is equal to A. So we have A is equal to 10. So the number of students who offer both subjects is 10. So we select option C. Question 2. In a sports contingent, there are 20 players in the football team and 18 players in the hockey team. So let's represent something since we have our Venn diagram. So we have football team with 20 players and hockey team with 18 players. 4 players play both football and hockey. So the intersection of the two circles, we have 4. We are to find the number of players in the contingent, that is the universal set. We have to find the universal set, and then B, the number of players who play only football or only hockey. So now let's find the number for the remaining regions. So for football, we have 20 players. And then when you take the football circle, we have 2 regions. So here is for what should be here. So that should be 20 minus 4. That gives us 16. Hockey circle, that is 18. So if one part is 4, then the remaining part must be 14. So we are assuming that there is no player who does not play any of the 2 games. So outside the 2 circles, that is 0. So we have to find U. Remember we said that in a 2-set problem, basically we have 4 regions. So when we sum up these 4 regions, it should give us the universal set. So we have 16 plus 4 plus 14 plus 0. And this must be equal to the universal set, which is U. So 16 plus 4, that is 20. And then 20 plus 14, we have 34. So 34 is equal to U. Therefore, U is equal to 34. So that is for A, the number of players in the contingent. Then B, we are also to find the number of players who play only football. So only football, we have 16, or only hockey, 14. So 16 plus 14, and that gives us 30. So we could say that A is 34 and then B is 30. So we select option B. Question 3. In an examination, every student study history or geography or both. So we have 2 different subjects. We have history, so H for history, and then G for geography. Well, what is the meaning of this particular statement? In an examination, every student study history or geography or both. What it means is that no student study neither of the 2 subjects. So that is the meaning of that particular statement. Now, out of 500 candidates, so there is a total of 500 candidates. So that is our universal set, 500. 60% took history, while 72% took geography. So the number of people who took history has been given in terms of percentage. So let's calculate 60% of the universal set. 60% of 500 candidates. So that is 300 students. So for history, we have 300. Now 72% took geography. So let's also calculate 72% of 500 candidates. 72 360. So the actual number here is 360. So what are we supposed to find? How many candidates took both subjects? So we are looking for the intersection. So I can represent that as x. Now let's find the expression for hockey only. So that will be 300 minus x. Geography only, we have 360 minus x. Remember, we said that in the two sets, the sum of the four regions must be equal to the universal set. So the first region we have 300 minus x plus the second region x plus the third region we have 360 minus x plus the fourth region, which is 0, must be equal to 500. So 300 plus 360 plus 0, we have 660. Then minus x and positive x will cancel out. We are left with minus x is equal to 500. So let's group like terms. Numbers on the left, 660 minus 500. This must be equal to x. So let's see. 660 minus 500. We have 160. And this must be equal to x. Therefore, x is equal to 160. So we have 160 candidates who took both subjects. So we select option D. Question 4. In a class of 50 students, the universal set number of students in the class 50. 30 offer economics. So E for economics 30. 17 offer government. G for government. We have 17. And 7 offer neither economics nor government. So outside the two regions, we have 7. How many students offer both subjects? So we want this region. I'm representing that as Y. So next, let's find the expression for economics only. So economics only, we have 30 minus Y. Government only, we have 17 minus Y. Remember that in the two set problem, we have 4 different regions, and the sum of the expressions for all the 4 regions must be equal to the universal set. So the first region, we have 30 minus Y plus the second region, Y, plus the third region, 17 minus Y, plus the fourth region, 7. This must be equal to 50. So we have 30 plus 17 plus 7. So we have 54. And again, you see that some of the variables can cancel out. Minus y and then positive y. These two will cancel out. We are left with minus y being equal to 50. So let's group like terms. 54 minus 50. This must be equal to y. So 4 is equal to y. Therefore, y is equal to 4. So we have 4 students who offer both subjects. So we select option A. Question 5. It was found out that out of 110 students in a school, so the total number of students, that is the universal set, we have 110. 20 read both newspapers and storybooks. So we have two different documents. The first one is newspapers, so N for newspapers, S for story books. Then we have 20 students who read both newspaper and then storybooks. 10 read neither newspapers nor storybooks, so we have 10 outside the two regions. And thrice as many students read storybooks as read newspapers. So we have this word here, thrice. In algebra, the word thrice means 3 times. 3 times. So you want to compare the number of students who read newspapers and story books. So we can do the comparison. Let's take note. Thrice as many students read storybooks as read newspapers. So it means that the number of students who read storybooks are more than the number of students who read newspapers. If I represent the number of students who read newspapers as A, then when we compare the two, 3 times of the number should give us that of the storybooks. Thrice means 3 times. So if A is for newspapers, then thrice, which is 3 times A, 3A will be for story books. So we can represent this. If I represent the number of students who read newspapers as A, then it means that for storybooks we should have 3A. That is the algebra. And that is a trick for this particular question. So the next thing we do is that we need to find the expression for newspapers only, and that should be A minus 20. Storybooks only, we have 3A minus 20. Now we know that in a two set, the sum of the four regions must be equal to the universal set. So we have the expressions for the four regions. Now the first region we have A minus 20 plus the second one we have 20 plus the third one we have 3A minus 20 plus the fourth 10. This must be equal to the universal set, which is 110. So let's simplify. So A plus 3A, we have 4A. Then negative 20 and positive 20, these two will cancel out. So we are left with minus 20 plus 10. That also gives minus 10. And this must be equal to 110. So we have 4A being equal to 110. We transpose this to the right, we have plus 10. So let me write this here. We have 4A being equal to 110 plus 10, 120. We divide both sides by 4 since we are looking for A. So we have A as 30. So for I, we have to find the number of students who read newspapers. So newspapers, that is A. Newspapers. So newspapers, we had 30 students. Now we are also to find the number of students who read storybooks. Storybooks. And we know the expression for storybooks. The expression for storybooks is 3A. Then 3A means 3 multiplied by A. Remember, we had A as 30. 3 multiplied by 30, we have 90 students. So that is for I. So the answer is 30 students, and then we have 90 students. So we select option A. Question 6. A survey of reading habits of 100 students. So we have our universal set, 100 students. Show that 30 read both comics and novels. So two different documents. C for comics and for novels. So 30 read both. So the intersection we have 30. 10 read neither comics nor novels. So 10, neither of the two. And twice as many students read comics as read novels. So algebra again. Comics, novels. In algebra, what is the meaning of the word twice? Twice means two times. Twice means two times. So let's compare the two documents. So twice as many students read comics. So it means that the number of students who read comics are more than the number that read novels. So if you represent the number of students who read novels as, let's say, y, then twice of y will be 2y. So we have 2y for comics and then y for novels. So let's find the expression for comics only. So comics only, we have 2y minus 30. Novels only, we have in terms of y. So we have y minus 30. And we know that in the two set problems, when we sum up these four regions, that should be equal to the universal set. So the first one we have 2y minus 30 plus the second one we have 30 plus this expression y minus 30 plus 10. And this must be equal to the universal set, which is 100. So 2y plus y, we have 3y. And again, minus 30, positive 30. These two will cancel out. We have minus 30 plus 10. This gives minus 20. And this must be equal to 100. So we have 3y equal to 100 plus 20. So we have 3y being equal to 120. Because we are looking for y, we divide both sides by 3. So we have y as 40. So that is for novels. So we have 40 students who read novels. So that is for I. Then comics only. Comics only. So from the Venn diagram, what is the expression for comics only? So comics only, we have this particular expression, 2y minus 30. But what is y? Y is 40. So we have 2 multiplied by 40 minus 30. 2 multiplied by 40, we have 80 minus 30. And then 80 minus 30, we have 50. So that is for I. So we have 40 students, and then we have 50 students. So we select option D. Question 7. in a class of 40 students, so the universal set here is 40. The number of students who study French is 10 more than the number of students who study history. We have two different subjects, F for French, H for history. But again, we are told that the number of students who study French is 10 more than the number of students who study history. So if you represent the number of students who study history as X, then 10 more than X will be X plus 10. In algebra, more than denotes addition. So those finding it difficult, let's look at this particular example. Let's say we have this number, which is 5. If I ask you to write a number which is 3 more than 5, 3 more than 5, what would be your answer? So the number which is 3 more than 5, that is 8. How did you get the 8? 3 more than 5, you just add 3 to 5, and that gives us 8. So this time you're looking for 10 more than X. So we just add 10 to X. So that is how we got X plus 10. Now, if 8 students study both French and history, so the intersection we have 8, then how many students study French? So it is assumed that none of the two subjects, that is 0. So let's find the expression for French only. So for French only, that will be X plus 10 minus 8. And then history only, we have X minus 8. Now we know that in a two-set problem, we have 4 different regions. And then when we sum up these 4 regions, that should be equal to the universal set. So the first one, we have X plus 10 minus 8. Then we have plus 8. We have plus X minus 8 plus 0. This must be equal to 40. So we can do away with the brackets. This must be equal to 40. So now X plus X, we have 2X. And then you could see that negative 8 and positive 8 will cancel out. 10 minus 8, we have 2. So 10 minus 8 plus 0, that is 2. And this must be equal to 40. So we have 2X equal to 40 minus 2. And then 2X is equal to 38. For now, we are looking for X. So what do? We divide both sides by 2. So here by 2, here by 2. So the 2 will cancel out, leaving X is equal to 38 divided by 2. We have 19. So that is for X. So meaning that the number of students who study history is 19. But then we are looking for the number of students who study French. So what is the expression for the number of students who study French? We have X plus 10. But what is X? X is 19. So 19 plus 10, that is 29. So we select option D. Question 8. In a survey conducted at Makola Market, 1/4 of the traders who sell tomatoes also sell onions. So we have two different commodities. Tomatoes, T for tomatoes, and then N for onions. So how do we write 1/4 of those who sell tomatoes? So that is 1/4 T, for T represents traders who sell tomatoes. 1/4 T. So this expression here also represents those who also sell onions. So mean that the intersection of tomatoes and onion circle is 1/4 of t. Again, to feed cell only tomatoes. So this is only tomatoes. The fraction is giving us to feed. And then 11 out of 20 cell onions. The whole of this circle. 11 out of 20. We have to find the fraction of traders who sell tomatoes. That is, we have to find t. We have to find the fraction for t. So for the fraction of t, or first, yes, for the fraction of t, that is for the whole of this circle. And you can see that the circle has been divided into two. So when we sum up these two regions, that should be equal to t. So let's work it out. So 2 out of 5 plus 1 out of 4t must be equal to t. So let's group like terms. We have 2 out of 5. This must be equal to t minus 1 out of 4t. 2 out of 5 being equal to t minus 1 out of 4t. So the coefficient of the first t is 1. The coefficient of the second t is 1 out of 4. And then 1 minus 1 out of 4, that is 3 out of 4. So 3 out of 4t. 3 out of 4t. Remember, we are looking for t. So because you are looking for t, we have different approaches. But in my case, I'm going to multiply each term by the reciprocal of 3 out of 4. So the reciprocal of 3 out of 4 is 4 out of 3. So I have 4 out of 3 multiplying 2 out of 5. And this must be equal to 4 out of 3 multiplying 3 out of 4t. So 4 out of 3 times 2 out of 5, we have 8 out of 15. And this must be equal to, so the whole of this will be simplified as 1. So this is equal to t. So t, we have 8 out of 15. So in your case, you can also divide both sides by 3 and 4. You should also get the same answer. Let's see, 2 out of 5. Okay, so 2 out of 5 being equal to 3 out of 4t. When you divide both sides by 3 on 4, 3 on 4, this will cancel out. And then 2 on 5 divided by 3 on 4. This is equal to 2 on 5 times 4 on 3. And this will also give you 8 on 15. So which other way you prefer, you still get the same answer for t. And we know that the fraction of traders who sell tomatoes is 8 out of 15. So we are done with the A. Now B. If the number of traders involved in the survey is 5. Okay, let's see. The number of traders involved in survey. Okay, so we have to find, we have to find the number of traders involved in the survey if 5 traders sell neither of the two commodities. So to solve this particular question, we need to try as much as possible to get the fraction of traders who sell neither of the two commodities. That is the first thing we should do because the emphasis was on neither of the two commodities. So let's find the fraction of traders who sell neither of the two commodities. So now, okay, so now we know that T is 8 on 15. So let me quickly redraw this Venn diagram here. And then we input some of the fractions. So what should be the universal set? We know that fraction is part of a whole. part of a whole. So it means that the whole should be 1. If fraction is part of the whole, then the whole is 1, because you could see that all the information given was given in terms of fraction. So the universal set here is 1. Now we know T as 8 on 15, onion 11 on 20. So let's find 1/4 of T. So that would be for both, since we know T. So 1/4 of T. T, that is 8 on 15. 4 goes here, 1, 4 goes here, 2. So we have 2 on 15. So for both, the actual fraction is 2 on, sorry, the actual fraction is 2 on 15. Here we have 2 on 5. So what fraction should be here? So the fraction here will be onion. Fraction for onion, 11 out of 20 minus 2 on 15. So what is 11 out of 20 minus 2 on 15? So that is 5 on 12. So this fraction here is 5 on 12. We can compute this using the calculator. Now we know that in a two-set problem, there are 4 regions. 1, 2, 3, and then neither. So let's represent the fraction of traders who trade in neither of the two commodities as, let's say, X. So when we sum up the fraction for these 4 regions, that should be equal to the universal set, which is 1. So let's solve for X. So X will be equal to 1 minus 2 on 5 minus 2 on 15 minus 5 on 12. So what is X? 1 minus 2 on 5, 1 minus 2 on 5, minus 2 on 15, minus 5 on 12. I have 1 on 20. 1 on 20. So that is the fraction for neither of the two commodities, 1 on 20. So now we are looking for the actual number that corresponds to the universal set. Now the number of traders who are involved in neither of the two commodities in terms of fraction is 1 on 20. 1 on 20. And this corresponds to 5 traders. That is their actual number, 5 traders. So let me even use okay, so that is it, 5 traders. So which fraction corresponds to the universal set? So the fraction that corresponds to the universal set here is 1. So 1 must also correspond to a particular uh, number of traders. So let me represent that as, let's say, A. So let's solve for A. We can apply proportion. I'm going to use proportion to solve for this. So let's do that. I want a space. So let me clean this portion. So I want a space. So we can apply proportion. How do we apply proportion? If 1 out of 20 goes with 5 traders, then 1 as a fraction must correspond to A. They are in proportion. They are in direct proportion. An increase goes with an increase, and a decrease goes with decrease. Now, 1 out of 20 is to 5. Can be written in terms of division. You know that is 2 also denotes division. So 1 out of 20 out of 5. This must be equal to 1 out of A. 1 is to A can also be expressed as division. That is 1 out of A. Now let's simplify what we have here. 1 out of 20 divided by 5. So this translates to 1 out of 20 times 1 out of 5. So that gives 1 out of 100. So we have 1 out of 100 being equal to 1 out of A. What are we looking for? We are looking for A. We are looking for A. So when you compare the numerators, we have 1, 1, they are the same. So because of that, we can compare the denominators. And comparing the denominators, we have A as 100. So that is 100 traders. So we should be able to select the correct answer. So for the fraction of traders who sell tomatoes, we had 8 out of 15. We had 8 out of 15. And then the total number of traders, we also had 100 traders. We had 100 traders. So you should be able to select the right answer. So what should be the right answer? 8 out of 15 and then 100 traders. We select option D. Question 9. In the class of 48 students, so we have our universal set, that is 48. It is known that 24 of them offer arts. So A for arts, 24. 20 offer chemistry. C for chemistry, so 20. And 22 offer biology. B for biology. All the students offer at least one of the 3 subjects, meaning that the number of students who offer neither of the 3 subjects is 0. 7 offer arts and biology. So art and biology, you are looking at the intersection of the arts and biology circle. So these 2 regions. When you sum up these 2 regions, that should give us 7. Again, 6 offer arts and chemistry. The intersection of the arts and chemistry circle. When we sum up these 2 regions, that should also give us 6. And 8 offer chemistry and biology. So again, the intersection of chemistry and biology circle, giving rise to these 2 regions. So these 2 regions must also sum up to 8. We are told that 3 students offer all the 3 subjects. So all the 3 subjects, we have 3 students. So once you've been able to fill all the 3 subjects, you should be able to fill the 2 regions. So let's begin. 7 offer arts and biology. So the intersection of the arts and biology circle, these 2 must sum up to 7. So if one region is 3, then the remaining region must be 4. Then 6 offer art and chemistry. Art and chemistry circle, the intersection. These 2 should sum up to 6. So if one region is 3, then the other region must also be 3. 8 offer chemistry and biology. So chemistry and biology. The intersection of the two, these two regions must sum up to 8. So if here is 3, and the remaining region must be 5. Then we are to find the number of students who offer only one subject. Then B, chemistry and biology, but not art. So now let's fill out the remaining region, that is art only, chemistry only, and then biology only. So let's begin with art only. So for the art circle, we have 4 regions. So 1, 2, 3, 4. So these 4 regions should sum up to 24. So what should be here? So you can calculate that. So we have 24 minus 3 minus 3 minus 4. 24 minus 3 minus 3 minus 4. So that is 14. That is 14. So that only will be 14. Let's also calculate chemistry only. The whole of this chemistry circle must sum up to 20. So we want this remaining part. So 20 minus 3 minus 3 minus 5. We want this. So let's see. 20 minus 3 minus 3 minus 5. 9. The chemistry only is also 9. Let's also calculate for biology only. The whole of the biology circle sum up to 22. So we want biology only. So 22 minus 4 minus 3 minus 5. 10. So biology only, we have 10 students. Now that we've been able to fill out all the 8 regions, should be able to calculate for every information given in the question. So A, you have to find the number of students who offer only one subject. A, only one subject. So only one subject. Which regions are we going to add together? So only one subject, art only, chemistry only, and then biology only. So let's sum them up. 14 plus 9 plus 10. 14 plus 9 plus 10. We have 33. That is for only one subject. And then B, chemistry and biology. Chemistry and biology. But but not arts. So which region? Chemistry and biology, but not arts. Let's find out from the Venn diagram. So chemistry and biology. Chemistry intersection biology. So we have these two regions. That is for chemistry and biology. The person says chemistry and biology, but not arts. So we need to do away with the arts. Remember, chemistry and arts only gave us these two regions, chemistry and biology, these two regions. But even within these two regions, we also need to exclude arts. We need to do away with arts. So we don't want arts. So what is the remaining region? That is only this region. The only region here contains 5. So the answer is 5. So that is for the B, 5. So the answer for A is 33 and the answer for B is 5. So we select option D. Question 10. In a senior high school, there are 174 students in Form 3. So we have our universal set 174. Of these, 86 play table tennis. T for table tennis. 84 play football. F for football. And 94 play volleyball. So V for volleyball, 94. 30 play table tennis and volley. So the intersection of table tennis circle and volleyball circle. So these two regions must sum up to 30. 34 play volleyball and football. So volleyball and football circle, the intersection, two regions. These two regions must sum up to 34. And also 42 play table tennis and football. Table tennis intersection football. These two regions must sum up to 42. Now each student plays at least one of the three games, meaning that neither of the three games is 0. You have to find the number of students who play A, all the three games, and then B, exactly 2 games. So now this is what we are going to do. Since we don't know the number of students who play all the three games, we are going to represent that as X. So we have X for the number of students who play all the three games. Once we've been able to fill all the three games, we should be able to fill the remaining regions. So remember we were told that 30 play table tennis and volley. So the intersection of table tennis and volleyball circle, these two regions. We said that these two regions must sum up to 30. So if here is X, then the remaining region must be 30 minus X. Next, 34 play volleyball and football. The intersection of volleyball and football, these two regions, must sum up to 34. So if here is X, then the remaining region must be 34 minus X. And then lastly, 42 play table tennis and football. Table tennis and football. So the intersection, these two regions, must sum up to 42. So if here is X, then here will be 42 minus X. The next thing we do is that we also need to find the expression for the remaining region. That is table tennis only, football only, and then volleyball only. So let's begin with table tennis only. When we pick the table tennis circle, we have 4 regions. 1, 2, 3, 4. So these 4 regions must sum up to 86. So if that's the case and then we want this remaining region, then we need to subtract the expression for the 3 other regions from 86. So we have 86 minus. So the first expression here we have 42 minus X minus the expression here, that is X, then minus this region, 30 minus X. So let's expand. We have 86 minus 42 plus x minus x minus 30 plus x. So let's work out the numbers. 86 minus 42 minus 30. We have 14. And we could clearly see that plus x and the minus x will also cancel out, leaving plus x plus x. So this is the expression for table tennis only. 14 plus x. Let's also work out that of football only. So we need to repeat the same process. So the whole of the football circle is 84. So because we are looking for football only, we need to subtract the three other regions from the football. So we have this region, 42 minus x, then minus this region, x, then minus this region, 34 minus x. So let's expand. We have 84 minus 42 plus x minus x minus 34 plus x. So let's work out the numbers. Let's simplify. 84 minus 42 minus 34. We have 8. See that for the variables, plus x and minus x will cancel out, leaving plus x. So this is the expression for football only. 8 plus x. Then lastly, volleyball only. Volleyball, all the four regions, 1, 2, 3, 4, should sum up to 94. So we are looking for the remaining regions. So we have to subtract the expressions from the three other regions from 94. So the first one, I have minus 30 minus x, then minus x, then minus 34 minus x. So we expand, we have 94 minus 30 plus x minus x minus 34 plus x. So let's simplify the numbers. 94 minus 30 minus 34. So we have positive 30. And you could also see that the variables can cancel out. Plus x minus x will cancel out. We are left with plus x. So this is the expression for volleyball only. 30 plus x. Now when it comes to three set problem, we have 8 regions. We can verify and see 1, 2, 3, 4, 5, 6, 7 plus neither of the three spots, making 8. When we sum up these 8 regions, that should be equal to 174. So let's start. 14 plus x plus this region, 42 minus x plus this region, 8 plus x plus this region, 30 minus x plus this region x plus 34 minus x plus 30 plus x plus 0. This must be equal to 174. So we have, I'm doing away with the bracket, 14 plus x plus 42 minus x plus 8 plus x plus 30 minus x plus x plus 34 minus x plus 30 plus x plus 0 is equal to 174. So let's simplify the numbers. So for the numbers, we have 14 plus 42 plus 8 plus 30 plus 34 plus 30 plus 0. That gives us 158. Let's also work out the variables. So for the variables, plus x and the minus x will cancel out, plus x minus x will cancel out, plus x minus x will cancel out, leaving plus x, and this must be equal to 174. Let's solve for x. So we have x is equal to 174 minus 158. So x is equal to 174 minus 158, 16. So x is 16. That is for all the three games. So all the three games they have 16 students. Now B, exactly two games. Exactly two games. So what do you mean by exactly two games? So for exactly two games, you are looking at these regions. So when we sum up these regions, that should give us exactly two games. First, we have 42 minus x and plus 34 minus x plus 30 minus x. But we know that x is 16. So let's do the substitution. So we have 42 minus 16 plus 34 minus 16 plus 30 minus 16. 42 minus 16, 26. 34 minus 16, 18. Then 30 minus 16, we have 14. So finally, let's simplify. 26 plus 18 plus 14. This gives 58 students. So for A, we have 16 students, and for B, we have 58 students. We select option A. Question 11. There are 70 women in a club. So we have our universal set 70. Each plays at least one of the following games. So the games, we have volley, V for volley, B for basketball, and then T for tennis ball. So if each plays at least one of the following games, then it means that neither of the three games is 0. Now 20 play volleyball only. So this is volleyball only because it is describing only one region. We can easily represent that. 10 play basketball only, one region, 10, and 6 play table tennis only. So we play 6 here. 4 play all the 3 games. So we have 4. This is a crucial aspect of the question. And an equal number play 2 games only. What is the meaning? An equal number play 2 games only. So first of all, let's identify the regions that describe 2 games only. So 2 games only, we are talking about the sum of this region, and then this region. When we sum up these 3 regions, that will give us the number of women who play exactly 2 games or 2 games only. And again, we are told that an equal number play 2 games only. So it means that the number of women who play for this region is the same as the 2 other regions. So I'm representing that as Y. I'm representing that as Y. So we have Y, Y, and then Y. Because the question said an equal number play 2 games. So we have to find the number of women who play volleyball. So first of all, let's solve for Y. We already know that in a 3-set problem, there are 8 regions. 1, 2, 3, 4, 5, 6, 7, 8. And then when we sum up these 8 regions, that should be equal to the universal set. So let's start. We have 20 plus Y plus 10 plus Y plus 4 plus Y plus 6 plus 0 must be equal to the universal set, which is 70. So let's simplify. 20 plus 10, that is 30. 30 plus 4, 34 plus 6, 40 plus 0, so it's still 40. Now for the y plus y plus y, we have 3y, and this must be equal to 70. So let's group like terms. Variable on the left, so 3y is equal to 70 minus 40. So we have 3y being equal to 70 minus 40, that is 30. We divide both sides by 3. 3 cancel out, so y is 10. And then we are looking for the number of women who play volleyball. So the volleyball, we have 4 regions, 20, Y, 4, and then Y. When we sum up these 4 regions, that should give us the number of women who play volleyball. So we are looking for number of women who play volleyball. So we have, so that is Venn. We have 20 plus y plus 4 plus y. But we know that y is 10. In place of y, we substitute 10. So we have 20 plus 10 plus 4 plus 10. 20 plus 10, 30. 30 plus 10, 40 plus 4, giving us 44. So we select option B. Question 12. 50 children had a choice of beans, plantain, and rice. So we have our universal set, which is 50 children. We have 3 food items. So we have beans, B for beans, P for plantain, and R for rice. 21 of them took beans, 24 took plantain, and 18 took rice. 3 took beans only. Because it is one region, we can represent that. 9 took plantain only, and then 2 took rice only. Then we are told that 5 took all the food, all the 3 items of food. Now we have to find the number of children who took plantain and beans only. That is for A. And then B, none of the 3 food items. So before we can do that, we need to find the expressions for the remaining regions. So that's what I'm doing. I'm placing X at this particular region. So what will be the expression for this particular region? So when we take the bean circle, we have 4 different regions. The sum of these 4 regions must be equal to 21. So if that is the case, and then we are looking for this region, we need to subtract 1, 2, 3 regions from 21. So we have 21 minus 3 minus x minus 5. 21 minus 3 minus 5. We have 13 and then minus x. So this is the expression for this particular region. 13 minus x. Now, again, when we take the plantain circle, we have 4 regions, but we are looking for this region. So we have to subtract these 3 regions from 24. So we have 24 minus x minus 9 minus 5. Let's simplify the numbers. 24 minus 9 minus 5. We have 10 minus x. So that is the expression for this particular region. Now let's solve for x. How do we solve for x? Remember in the question we asked to find the number of children who took none of the 3 food items. That means that we have an unknown number outside the 3 regions. So if that's the case, then it means that we cannot add the remaining 7 regions and equate to 50. We know that in a 3 sets problem, we have 8 regions. Then when we sum up the 8 regions, that should be equal to 50. So here is the case, we don't know the exact number who took none of the three food items. So we cannot add the other regions and equal to 50. So there must be an alternative solution. Now let's look at the rice region. We have 4 different regions inside the rice region. So when we sum up these 4 regions, that should be equal to 18. So let's do that. Now the first one, we have 13 minus x. We have plus 5. We have plus 10 minus x plus 2. This must be equal to 18. So let's simplify the numbers. 13 plus 5 plus 10 plus 2. We have 30. And then minus x, that gives minus 2x. And this must be equal to 18. Let's group like terms. Numbers on the left, variables on the right. So what is 30 minus 18? So 30 minus 18, we have 12. So 12 is equal to 2x. Because we are looking for x, we divide both sides by 2. So here is 6. So 6 is equal to x. Therefore, x is equal to 6. So now, can we find the number of children who took plantain and beans only? Plantain and beans only. So the intersection of plantain and beans circle. So that is these two regions. These two regions is plantain and beans. But then we are looking at plantain and beans only. So we need to exclude the rice circle. So we are left with only x. We are left with only x. And we all know that the value of x is 6. So that is the answer for A. Plantain and beans only. We have 6. Now B, none of the 3 food items. So none of the 3 food items, we are looking at this particular region. So we have different ways of solving this. So this is what I'm going to do. I'm going to represent the number of children who chose none of the 3 food items as y. So let's solve for y. So how do we solve for y? So when we sum up these 8 regions, that must be equal to 50. 1, 2, 3, 4, 5, 6, 7, 8. That must be equal to 50. That is one way of solving that. We can also do an easier way. We know that the whole of the rice circle is 18. So we have 18. Then we are left with 1, 2, 3 regions. So plus 3 plus x plus 9 plus y. This must be equal to 50. Nothing has changed because in the rice region we have 4 different regions and the total of these 4 regions is 18. So since we wrote 18, we have catered for these 4 regions. And then we are left with 3, x, 9, and then y. So that is what we have. But then we know that x is 6. We know that x is 6. So anywhere we see x, we substitute 6. So we have 18 plus 3 plus 6 plus 9 plus y is equal to 50. So 18 plus 3 plus 6 plus 9, we have 36. So 36 plus y is equal to 50. Let's solve for y. So y will be equal to 50 minus 36. 50 minus 36, 14. So y is 14. So we now know our answer. So that A, we had 6, and then B, we are having 14. 6 and 14. We select option C. Question 13. In a certain class, 22 people take one or more of chemistry, economics, and government. So we have 3 different subjects: C for chemistry, E for economics, and then G for government. We have a total of 22 pupils. So if each student take one or more of these 3 subjects, it also means that neither of the 3 subjects we have 0. Now 12 take economics. We have 12 students offering economics. 8 take government, and then 7 take chemistry. Nobody takes economics and chemistry. What is the meaning? So first of all, we need to identify economics and chemistry region. So economics and chemistry, their intersection, we have 2 different regions. So these 2 represent economics and chemistry. And we are told that nobody takes economics and chemistry. So if nobody takes economics and chemistry, this can be represented numerically as 0. When we sum up these 2 regions, that should be equal to 0. So we have done that. Next, 4 people take economics and government. So economics and government, that is the intersection of the economics and government circle. So when we sum these 2 regions up, that should give us 4. So if here is 0, then here must be 4. We have to find the number of people who take both chemistry and government, and then government only. So we need to find the values for the remaining regions. So let's begin with economics. So economics has 4 regions: 1, 2, 3, 4. And the sum of these 4 regions must give us 12. So what number should be here? So here should be 8. Because 8 plus 4 plus 0 plus 0, that gives us 12. Now let's also place a variable here. Let's place a variable here and solve for the remaining region. So if I place x here, what should be here? So considering the chemistry circle, that should be 7 minus 0 minus 0 minus x. And this is simplified as 7 minus x. What should be here? So that is 8. We are considering the government circle. So 8 minus x minus 0 minus 4. 8 minus 4, that is 4. So 4 minus x. We have 4 minus x. And we know that in a 3-set problem, we have 8 regions. 1, 2, 3, 4, 5, 6, 7, 8. When we sum up these 8 regions, we should get a total of 22. So let's start. We have 7 minus x plus 0 plus 8 plus x plus 0 plus 4 plus 4 minus x plus 0 must be equal to 22. So let's eliminate the brackets. We have 7 minus x plus 0 plus 8 plus x plus 0 plus 4 plus 4 minus x plus 0 is equal to 22. So let's work out what the numbers. Let's simplify. We have 7 plus 8 plus 4 plus another 4. So the zeros will not change anything. So we have 23 for the numbers. Now the variables, minus x, positive x. These two will cancel out, leaving minus x being equal to 22. So grouping like terms, we have 23 minus 22, this being equal to x. So 1 is equal to x, therefore x is equal to 1. So now, let's see the number of people who take both chemistry and government. Both chemistry and government. So the intersection of the two circles, that is x plus 0, and x is 1. So 1 plus 0, that is x. So A, both chemistry and government, we have only one student. B, government only. Government only. So this particular region, the expression there is 4 minus x. We know that x is 1. X is 1, so minus 1. And this gives us 3. So we saw that A, the answer for A, we had 1. Then the answer for B, we had 3. So we select option A. Question 14. In a class of 70 students, so we have our universal set 70. 6 offer economics only. So with the subjects, we have 3 different subjects. So E for economics, M for mathematics, and J for geography. So in a class of 70 students, 6 offer economics only. Economics only. 6. 18 offer economics but not mathematics. So they offer economics. This is the economic circle, but not mathematics. So within the economic circle, we are doing away with mathematics. This is economics, but not mathematics. So we are left with these two regions. So these two regions represent economics, but not mathematics. And that should give us a total of 18. So if here is 6, then here must be 12, because 6 plus 12, that is 18. 36 offer economics and geography. Economics and geography, their intersection, these two regions, that is 36. So if here is 12, then what should be here? Here should be 24, because 12 plus 24, that is 36. 53 offer economics. So economics, we have 53. 50 offer geography. Geography, we have 50. And 34 offer mathematics and geography. Mathematics and geography, their intersection. The intersection is 34. So if here is 24, then here must be 10. All the students offer at least one subject, meaning that neither of the three subjects is 0. So we have to find the number of students who offer mathematics. So let's find the values of the remaining regions. So let's focus on the geography circle. We have 4 regions inside the geography circle, and their sum must be equal to 50. So what should be here? So we have 50 minus 12 minus 24 minus 10. 50 minus 12 minus 24 minus 10. That is 4. So here should be 4. What should be here? We need to consider the economic circle. 4 regions should give us a total of 53. So 53 minus 6 minus 12 minus 24. 53 minus 6 minus 12 minus 24. We have 11. So here is 11. So how do we calculate for mathematics only? Let me quickly represent that as x. You know that in a 3-set problem, we have 8 regions. And the sum of these 8 regions must be equal to the universal set. So we know that when you take the economic circle, we have 6 plus 11 plus 12 plus 24. Then we have plus x plus 10 plus 4 plus 0 should be equal to 70. 6 plus 11 plus 12 plus 24, that is economics. So the whole of this should give us 53 plus x plus 10 plus 4 plus 0, that is 14. And this must be equal to 70. So we have x being equal to 70 minus 53 minus 14. 70 minus 53 minus 14. So we have the value of x as 3. Now that we know that x is 3, can we calculate for the number of students who offer mathematics? So mathematics, that is m. So the total here must be equal to the sum of 11, 24, 10, and then x. We are looking at the mathematics circle. 4 regions, 11, 24, 10, and then x. But what is x? X is 3. So m, let's see, 11 plus 24 plus 10 plus 3. We have 48 students. So that is for A. Let's also look at that of B. We have to find the probability of selecting a student at random from the class who offers geography only. Geography only. So geography only. That will be the number of students who offer geography only. We have 4 divided by the total number of students, which is 70. So let's reduce it to the lowest form. 4 divided by 70, we have 2 on 35. So for the A part, we had 48 students, and for the B, we had 2 on 35. So we select option B. Question 15. This is the last question of the test. So in a survey of 100 outpatients, so we have a total of 100 patients, that is our universal set, who reported at the hospital one day. It was found out that 70 complained of fever. So F for fever, we have 70. 50 complained of stomach ache. So S for stomach ache, 50. And 30 were injured. I for injured patients, 30. So all 100 patients had at least one of the complaints. So meaning that neither of the 3 is 0. And 44 had exactly 2 of the complaints. 44 patients had exactly 2 of the complaints. So can we identify the region for exactly 2 complaints? So when we sum up this region, and then this region, that should give us 44. So that's what we are going to do. We are representing here as A, here as B, and here as C, with the idea that A plus B plus C must be equal to 44. So how many patients had all the 3 complaints? So all the 3 complaints, I'm representing that as X. We are looking for X. So before we can do that, we need to find the expression for fever only, stomach ache only, then injury only. So let's work it out. Now let's start with fever only. So with fever, we have 1, 2, 3, 4, 4 regions. And these 4 regions should sum up to 70. So since we are looking for this, we need to subtract the 3 regions from 70. So that will be for fever only. We have 70 minus A minus B minus X. Now stomach ache only. So for origin, this should sum up to 50. So we have 50 then minus A minus C minus X. So let me quickly represent that. We have 50 minus A minus C minus X. And then injury only. So injury only, we have 30 minus B minus C minus X. 30 minus B minus C minus X. So that is for injury only. And we know that in a 3-set problem, we have 8 regions. Then the sum of these 8 regions must be equal to the universal set. So let's start. We have 70 minus A minus B minus X. So that is for F only. We have plus A plus B plus X. Then plus 50 minus A minus C minus X. So we are done with this. We have plus C, and then this one, injury only. So 30 minus B minus C minus X plus 0, and this must be equal to the universal set, which is 100. So now let's simplify. Starting with the numbers. 70 plus 50 plus 30 plus 0. 70 plus 50 plus 30 plus 0. That is 150. So we have 150 for the numbers. Let's also check for the variables. So with the A, this is minus A and then positive A. They will cancel out. Minus B, positive B. They will cancel out. Minus C plus C. They also cancel out. So we are left with minus A. We are left with minus B and then minus C. Now let's also focus on the X. So the X, we have minus X plus X. They will also cancel out. So we'll be left with minus X minus X, and this will give us minus 2X. So this must be equal to 100. So we have 150. I'm going to factorize minus 1 out from the A, B, and then C. So minus 1 out, we are left with A plus B plus C. Remember, we knew that A plus B plus C must be equal to 44. So we are left with minus 2X. And this must be equal to 100. So we have 150 minus So we saw that A plus B plus C is 44 because we were told that 44 had exactly two of the complaints. So the two of the complaints, we saw three different regions. So that is A plus B plus C must be equal to 44 to solve this. So in place of A plus B plus C, we substitute 44. Then we have minus 2x is equal to 100. So let's group the items. Numbers on the left, variables on the right. We have 150 minus 44. And you transpose 100, we have minus 100. And this must be equal to 2x. So what is 150 minus 44 minus 100? So we have 6 being equal to 2x. Because we are looking for x, divide both sides by 2. So we have 3. So these two will cancel, is equal to x. Therefore, x is equal to 3. We select option C. Since we are looking for the number of patients who had all the 3 complaints, and we represented that as x. So this brings us to the end of this particular text. Thank you.